Hello. Today we're looking at how do we determine a function's extrema, and then later we'll do how do we find average rates of change. So before we get into extrema, first we have to know when a function is increasing, decreasing, or constant. So all of these are read as x increases, so from left to right. So increasing, as x increases, f of x increases, right? F of x, these y values are increasing. For decreasing, as x increases, f of x decreases, so this would be decreasing. And then finally, constant, as x increases, f of x stays the same, so just get this flat line. And so let's look at some examples. Let's estimate the intervals that these functions are increasing or decreasing. As you can see here, even though this graph changes shape, as we go from left to right, the y values are constantly decreasing. So we can say that this function is decreasing on the interval -infinity to infinity. In this next example, we can see that the function increases, decreases, and then increases again. So our intervals are just for these x values of -1 and 1 here. So I can say that this function is increasing on the intervals -infinity to -1, and then union 1 to infinity. And then we can say that the function is decreasing from -1 to 1. And notice that I only use parentheses around here because at -1 and 1, it is both decreasing and increasing, so we just don't include that number. All right, and now looking a little bit closer at like these points, like right there and here, even though this one didn't change from increasing to decreasing, like each of these points has a name, and they all fall under critical points. What are critical points? They're points at which a line drawn tangent to the curve is horizontal or vertical. So like if I took this point right here and I drew a tangent to this blue curve, the tangent would be a horizontal line. Okay, so that makes that a critical point. We also have critical points here and here. And extrema are critical points where the function changes its increasing or decreasing behavior. So as you see here how it's increasing and then it switches to decreasing, that makes this point an extrema. Same with this point down here at the bottom. And this point right here where it doesn't change its increasing or decreasing behavior, just changes its shape and goes horizontal for a second, that's just a point of inflection. And these other points are called max and mins. And with max and mins we can have relative and absolute max and or mins. Relative max-mins are the highest or lowest point for a given interval, whereas absolute are the highest or lowest points over the entire domain. So let's look at these graphs. In this first graph, this would be a relative max because it's the highest point right here, and it's an extrema point where it changes from increasing to decreasing, but this is an absolute max because it's the highest over the entire domain. And minimums work the exact same way. This would be a relative minimum at this extrema and an absolute minimum at this extrema. So from a graph, you should be able to pick out points and talk about which type of extrema they are. All right, now let's move on to average rates of change. In algebra, you learn that the slope between any 2 points on a graph of a linear function, so a line, represents a constant rate of change. But for nonlinear functions such as this, the slope changes between different pairs of points. So we can only talk about the average rate of change between 2 points. All right, and the average rate of change between any 2 points, like this x1 f of x1 and x2 f of x2, is just the slope of the line through those points. And the line that goes through those points is called a secant line. And in calculus, you'll focus on bringing these 2 points closer and closer together to find a rate of change at an instantaneous point, but we're not going to worry about that right now. So how do we find the slope between those 2 points? Well, it's the same way to find slope as you always have. The slope of the secant line is f of x2 minus f of x1 over x2 minus x1. This is simply the change in the y values over the change in the x values. So let's give it a try. Find the average rate of change on the given interval for f of x equals -x cubed plus 3x on the interval -2 to -1. All right, so these points represent my x values. This is going to be my x1 and x2. So now I need to find f of x1 and f of x2 just by plugging them in and evaluating this function. All right, so first I found f of negative 2 just by plugging in negative 2 into this function, and I got f of negative 2 equals 2. Then you can do the same for negative 1. Find f of negative 1. F of negative 1 equals negative 2. So now I've got my y values, my x values, time to find the slope. So remember the equation, it's f of x2 minus f of x1. So we have f of x2 was negative 1, so f of negative 1 was negative 2. So you have negative 2 minus f of x1, 2, all over x2 minus x1, negative 1 minus negative 2, or just plus 2. So we end up with the slope being negative 4 over 1, or just negative 4. So the average rate of change for the function negative x cubed plus 3x on the interval negative 2 to negative 1 is negative 4. And that's how you find average rates of change. All right, and that's all for these notes. Goodbye.